Hello, my name is Mogens. Welcome. This talk will be a little different from the other NoSQL talks that's been on this track today, because they tend to talk a lot about the performance. But this talk will, as the title implies, focus on just how easy it is to get going with MongoDB and how frictionless development is with MongoDB. Right. I'm going to start by saying a few words about that are general to document-oriented databases, just so we level and we all know what we're talking about. Then I'm going to introduce MongoDB from a non.NET point of view, just pure MongoDB. Then I'm going to show how to use it with C#. I'm going to present a tiny web app that uses MongoDB as its only persistence mechanism. I'm going to sketch some bigger usage scenarios. This is where the enterprisey thing comes in. And finally, I'm going to say a few words about who some of the someones who are using it. Right. My goals with this session is to communicate that NoSQL can relieve us of some of the pain that we are experiencing. I don't know what kind of systems you're developing, but I'm a developer, and we primarily use relational databases as for persistence, and I like to create beautiful domain models, and I really want to persist them in my database, and that just hurts. So I'd like to see if maybe the world could be a little nicer. I'd like to spread the word that NoSQL is not only for open source hippies, that NoSQL can actually be used in enterprise environments, even in companies that are based on Microsoft technologies. And I hope that I will succeed in communicating enough understanding of MongoDB so the people perhaps will consider it if they need to perhaps consider some new technologies or something in the future. Yeah, I hope so. Who might be interested in this session? Developers who don't know too much about MongoDB. This is an introduction, so I won't go too much in depth. For instance, I won't touch all the different configurations that it can be deployed in, or anything about operating MongoDB. So this would be introductory level. Developers who feel the relational agony, like myself, and developers who are interested in technologies that are sort of agile in nature. I hope I can communicate the feeling to you that it's just flexible and agile working with MongoDB. And you don't have to be a .NET person to listen to this stuff, but there will be C# code. So you know who is saying all these weird messages. I'll just introduce myself. My name is Mogens. I'm a software pilot at Trifork, and I like to use open source software, and I primarily work on the .NET platform. I actually like to build great stuff for customers, and it's not even like my employer told me to put that in there. I actually do. I'm not an open source hippie, even though I tend to use open source products, but my experience is just that they are better at building great stuff for customers. And then I like to tinker with other cool technologies in my spare time. And I don't like technologies that impose pain on me when I develop stuff. And finally, like all fairly civilized people, I can be reached via email, Twitter, and I have a blog as well. Last thing before I get started, I'd like to try a tiny experiment. There's a web app called Priority Queue that can be used to collect questions in sessions like this. So if you have an iPhone or another mobile device, it could be fun if you could go here and ask a question, and you can go there and vote on other people's questions as well. Or you can just go there and look. I don't care. Right. First, a few words about document-oriented databases. Oh, the URL is here, so you don't have to, if you want to go there in the middle of the session. First, a few words about document-oriented databases. Document-oriented databases, they store documents. And when I first heard of this, I thought about PDF files and stuff like that. And that's not it. Documents here is, to be more precise, it's objects, and it's a special kind of objects because it's composite objects that consist of fields and other objects. So some kind of UML sketch of an object could be this, where you see there's one of these, and they are all aggregated in some kind of root object. So they don't have relations to each other down here. It's an aggregated composite object. That's a document. Document databases have some common properties. They tend to be schemaless. I've tried to draw an agile database. It's really flexible. They offer no kind of joins. So documents are alone in the sense that you can't select a document and with it have other documents that are somehow referenced from in there. They tend to have the document as the unit of atomicity. So either one document is updated or it isn't. An implication of some of the properties is that it can often be distributed, so that some documents are on some nodes, or perhaps they are replicated in various distribution configurations. And an implication of all of this is that they are often quite performant because there are no logs. So, yeah. There are quite a few document-oriented databases available, and I know that some of these might fall more into the key value store, Redis and Riak category, but somehow there are still document databases, or you can consider document databases some kind of key value store. They are there's a large intersection between all of these and what they can do. Yeah, and I think it all started with the Lotus Notes many years ago. But yeah, now we have MongoDB. So now I'm going to start talking about MongoDB and I'll also say a few words on what makes MongoDB stand out from the other document-oriented databases. The name comes from humongous, so that implies that it can be big somehow. It's developed and supported by a company called 10gen. It was originally a part of a platform as a service thing that 10gen were building many years ago. But then I think the company, they had a break where they didn't do any development on the platform, and then they pulled out their persistence mechanism and they call it MongoDB, and then they just concentrated on that. It's free and open source to use. It's absolutely free, so you can buy some commercial support, but you can also choose and just use it in any configuration you like. It's currently in a stable version 1.81. They follow the scheme where minor version numbers, when they're odd, it's a development version. It's, yeah, surprise, it's a document-oriented database, and it stores JSON documents. So documents in MongoDB are JSON. And what sets MongoDB apart from other document-oriented databases is that it can be ad hoc queried, it can perform in-place updates of documents, and it is not REST-based. So you have to have some kind of driver implemented for the platform that you're on. But there's official drivers for Ruby, PHP, Java, .NET, Scala, Erlang, any language and platform I can think of, and community-based for even more. So there are quite a few drivers available But it can expose a simple REST endpoint though, if you really want. Data in MongoDB is organized like this. We have a Mongo instance here. It contains any number of databases. Each database contains any number of collections, and each collection contains beautifully, uniquely shaped snowflakes, as you can see. So yeah, this implies that all the documents can be different and beautiful and unique. So it pretty much resembles your standard relational database in the structure. As I said, ad hoc querying and accompanying ad hoc querying are indexes, so you can make querying fast by creating an index first. And it supports normal indexes as well as geospatial indexes, which is a pretty cool feature. And server-side updates, as I said. And then there's a MapReduce implementation that can compute stuff and aggregate across documents. There's something called GridFS, which is an implementation it's a standard for streaming large blobs of data into several documents. So that if you want to save that 700 megabyte video file, you can do that in MongoDB. And MongoDB offers durability, either through replication like other NoSQL databases, or through journaling. So it can actually run in a durable mode, like your standard SQL server. And then it offers scalability and fault tolerance via an auto-sharding feature. You just tell Mongo which property to which field to shard on, and then it will make sure that the shards are balanced all the time. And it offers replica sets, which improves the fault tolerance. But today, I'll focus on just a little bit on the 3 first bullets here. Yes, in MongoDB, documents are JSON. So, for instance, this is a tiny document, and all documents, when they have been saved in MongoDB, get an ID, _ID. Either you assign the ID when you save it, or MongoDB assigns an object ID object to the ID field. Yeah, that's a simple document. In MongoDB, queries are also documents. So when you do a find, you specify the criteria by giving this tiny example document. Here I'm querying documents with a field called username and a value of Joe. I can also use a regular expression to query all documents where username has a Joe prefix. And I can use these special query operators with a $sign. Here I'm querying all documents where username has a value, either Joe or Mo. Updates are also documents. So either when I update stuff, I replace an entire document. That's done by specifying an ID. So if something in this collection has an ID of 21, that document gets replaced by this one. So that's one way of updating. Another way of updating is in-place updates. Here I use the $inc update modifier to increment a hit count by 1. And there are more complex update modifiers, like for instance add to set, which adds a set semantic to the tags field, which if it doesn't exist, it becomes an array of strings. And if new tag to add doesn't exist, it will be added. So it's pretty nifty. So let's see. I'm going to try and install MongoDB and connect with the shell that comes with MongoDB. I'm going to create a tiny database, and we'll do some queries and see what we can do. So first, I have cheated, and I've downloaded MongoDB in this zip file. So I'll just unpack it to my temp folder. And I'll go run it. So, can you see it down there? Now MongoDB is running. It actually, it has a, it says here that it's listening on port 27017, and that it has a web admin interface listening on port 28.17. Let's go look at that. So, when Mongo is running, you can get some information on stuff here. Yeah, you can see which databases are in the Mongo instance. Right, but I'm going to start a Mongo shell. I'm going to go to. Okay, I did it pretty fast before, but MongoD is the server. Now I'm typing Mongo. That's the Mongo shell. So now I'm connected to my local MongoDB instance. I can say show DBs to show which databases are in there. I can use some random database that's use in SQL Server. It switches the database context to some DB. I can show collections. There are none. That's because the DB doesn't exist yet, really. So let's try see db.sum collection.insert. And I'd like to insert what a document. Right, so now if I say show collections, I can see now that some collection exists. Moreover, there's a system.indexes collection, which has documents that describe all the indexes that exist in my database. So now, now I'd like to do some more stuff. Let's create a new database called Fairytale. Yeah, it's completely empty, as you can see. Let's insert a unicorn. Unicorns, insert. It's called, I googled for some cool unicorn names, so I'm going to use some of them here. Cake, caramel, majestic, yeah, twisty, and last one, horny. Unicorns.find. Find with no criteria, just returns all the documents. So I can see now that they have all been assigned an object ID, and the documents, the data is in there. Right, let's try writing a simple query. I can say unicorns.find. I'll give it a simple example document with the name cake, and it returns my cake unicorn. I can try querying by all the names that start with a C.
Is that a regex syntax?
Yes.
Should it be in quotes?
No. I think regexes are somehow native to JavaScript, so you can just do some slashes. So as you can see, it's pretty simple to query for data. And if I had an index on the name field, and I use simple regular expressions like prefix, it would use the index. But if sometimes it can use the index, so it would be a little slower. But you can still do it. And an example of a query operator, I can query by horns, and I give a document with $1. So all the unicorns with more than one horn. Right, that was some simple queries. Let's try updating something. Unicorns, update, and updates are specified by always giving some kind of criteria. If it's an empty document, then all documents are matched. And then comes the update document. So I'd like to perform an update where I set a new field in each unicorn. I'd like to set the likes field to an array, and they all like beer. And then I have to specify in an update statement, I have to specify two bools, whether to do an upsert That is, if none are matched, should it create a document? I just say false. And whether multiple documents should be updated. If I put false here, only the first match will be updated. So let's see if all my unicorns have now like beer. They do. And yeah, as you can see, it's all JSON, and arrays are just native to this. So I can put collections of stuff. I can even put collections of JSON objects in here. So that's pretty easy. Let's do something more advanced. I see unicorns, update. I'd like to update those with a name in this array, cake and majestic. And I'd like to, let's just finish this. I'd like to say add to set. And I'd like to add to the likes that they like peanuts. Let's see. So now, okay, I can't see the names now, but cake and majestic, they like peanuts now. Yeah. Okay, and since arrays are native to MongoDB as well, I can do a query where I find unicorns where likes contains the value peanuts. So when I give a criteria where the field is actually an array, it just searches for the value inside the array. And indexes work on that as well. Let's try looking at some indexes. Now, let's find all the unicorns with one horn. That's 4 out of 5. When I do this find, it actually doesn't return a result set. It returns an iterator that I can call more stuff on. I can say limit or I can say skip. And right now, I'll just try to say explain. This actually gives a document to me that says how is MongoDB going to execute this query. And I don't know what all of this stuff means, but I know that when it says basic cursor, it's what it corresponds to a table scan in a SQL server, and I can see that it n-scanned. It went through all of my documents, and I got 4 results. So that's not optimal. So let's try adding an index to the horns field. So I say db unicorns ensure index, and then I supply a document, and I say horns true. The 1 here means true. I can put -1 in here to make the index be reversed. And now,
What do you mean by reversed?
no, it means that it's. I think when I make a compound index, I think it's pretty relevant which way the index turns. Yeah, good question. Okay, let's try explaining now that I added the index. So now it says something with B-tree instead of basic cursor. And I don't know much about the database theory, but I know that the B-trees are usually what the databases use for their indexes. So this sort of implies that we are now hitting the index. Yeah, and we can see that the n scanned is equal to the number of returned results. So that probably couldn't be much better. Okay, last thing right now is I'm going to try to query by likes. That's the array, remember? All the unicorns who like peanuts, it says basic cursor. So let's try ensuring that there is an index on likes, and then let's try explaining the index again. And now it hits the index. So as you can see, it's pretty easy to get really fast queries running with MongoDB. Right. So before your very eyes, I installed MongoDB and I was inserting data and I got it running in just a few minutes. So now, just to try and compare, I'd like to try and install Microsoft SQL Server and try and connect with the SQL Server Management Studio and create a database with a table and just insert some, oh, yeah, you got me. No. Now. Yeah. Life's too short, really. Now, let's take a look at how to do this in C#. How many are .NET developers? Yeah. Okay. You didn't want to see Mark Seeman code on stage? Tempted? Okay. Great. It's just a shame that we had to talk at the same time, at the same slot in the schedule. That's too bad. But yeah, let's see how to do this with the C#. First, there are drivers available in .NET. There are quite a few actually. There's one official driver called Mongo C#, and there's quite a few community supported driver where the norm driver used to be the cool kid, but then 10gen went ahead and rewrote their .NET driver, and I think right now the official driver is actually pretty cool, and it's easy to get started with, and it follows the .NET way of writing code, so it's quite idiomatic and nice to use as a .NET developer. I really like it. So we're going to use that. It has two parts. It has the driver part that can connect and manage a database and interact with raw documents, like pull them out in BSON format and convert them to dictionaries and untyped stuff like that. And then there's the BSON serialization library that can be used by the driver to serialize and deserialize complex data types. And the BSON library can be pulled out if you feel like serializing stuff to BSON somewhere else. So yeah, back to code mode here. Let's try connecting with Mongo C# and doing some inserts, some querying, and lastly a complex model. Right. So I have a simple console, plain vanilla console application here, and I'll just add a reference to the Mongo driver. It's right there, and then I'll create the Mongo server. Just say create MongoDB / localhost. That's a Mongo server. I can say Mongo server get database fairytale to get my fairytale database. I can say Mongo database get collection unicorns, and now I have my collection of unicorns. And let's just do a simple query. Find all for each unicorn in all unicorns. Let's just try. I can never remember what comes out of this. And it's a BSON document, and I lost my. Let's just try. Let's just see what it. It can't build. Oh, I forgot a reference. Sorry. BSON. Yeah, that's much better. So now I can, as you can see, I have my index operator defined, and I can index by field name here. So let's just try outputting the name of each unicorn. And I get the names of my unicorns. So as you can see, it's pretty easy. 4 lines of code, and I'm already working with my unicorns. Let's try inserting something. Mongo collection.insert, and we're totally untyped dynamic mode right now. So I can just go ahead and insert your standard anonymous type here, and I'd like to add a new unicorn called Phoenix. It has one horn. Oh, it's JSON mode there. It has one horn, and it likes. What does it like? It likes to drink tea. Yeah. So let's just see if. Yeah. Now we have Phoenix in there. And let's go to the Mongo shell and see if the new unicorn is actually there. If I do find one, I can make it get me at most one result, one document. And then it formats the document a little nicer here. So I can see now I have a document totally same shape as the other documents, and I created this from C#. So as you can see, if you're satisfied working in untyped dynamic mode in your C# program, it's pretty easy to get working with MongoDB. But let's try doing something a little more complex. I have created a simple model class here called Unicorn. It's a class that has the same fields as that has fields that match all the fields in my documents. Can you see it down there? Or is it? Yeah. Unicorn class. It has a hash set that matches the set semantic I want with the likes array, and it has an object ID called ID. And then I have horns, name, and likes, properties, and I specify a lowercase name to match that of the documents, thus keeping my idiomatic C# uppercase property names. And then I have a simple to-string implementation here that just formats this unicorn in a nice way. So now, instead of getting this untyped collection of unicorns, let's just try adding this generic, specifying the type of the collection, and now suddenly my Mongo collection is a Mongo collection of unicorn. So now I should be able to. Now each unicorn is in fact a unicorn object, and to string will format it nicely, and I can just say console write line unicorn. Let's run this. So now you see all my unicorns formatted nicely. So as you can see, it's pretty easy actually to create strongly typed classes and just select stuff from MongoDB and have it mapped to my objects. Of course, that's not always what you want, but it's really nice to have the option when it is what you want. So let's try making this object a little more complex. So now I imagine that this unicorn has an address. And since we like to create beautiful domain models, we make this abstract address class that can format itself as a string. Then we implement it it's specialized as a foreign address that just consists of any number of address lines that are formatted by separating them with a comma. And then we have a domestic address. And I know it's supposed to have like 14 fields here in Denmark, but let's just say that 4 is enough. So now, address. We have an address on each unicorn. So let's just make an address property. And I add this. I like to keep it lowercase in the documents. So now I have a unicorn, and I can say .insert new unicorn. It's called a good unicorn name. Anyone? No? Prancer. Yeah, that's a good name. How many horns? One. Only Horny has 3 horns. And then Prancer likes eggs and bacon. And Prancer's address is a domestic address with the street equals Margrethe Pleasant, number is 4, city is beautiful city of Aarhus, and the postal code is 8000. Yeah. Now, let's run this. You can see Prancer already is returned from the database here, so it's supposed to inherit. Let's see if I go look for Prancer. So now I get this. Now it's a little more complex. So, and as you probably already are thinking, we have to have some kind of type information in here, because JSON just stores objects. And what kind of object is behind the address field? It has these fields, but there's not enough information to say which kind of strongly typed class it maps to in our strongly typed programming language. So the serializer is just nice enough to put an _t in here and just specify the type here. Right. So as you can see, it's pretty easy to insert even complex objects as documents in the database. This stuff is really a hassle with a relational database. You have to decide on which strategy you're using, if you're using a table per subclass or just shoving it all into one big table, it's a mess. So it's pretty easy to get going here. Right. So let's try doing an update. I have my collection, and I'd like to first thing, I'd like to find all the unicorns that have 3 horns. So now instead of find all, I say find. And now I use the class called query. It has some static properties, and I can just say horns equal to 3. So let's see if Horny doesn't show up. Yeah. So and this query class, let's just pull this one out. That's my criteria. It can be pretty complex because query, it has an and then you can specify 2, and then you can compose a large query. There's a great number of query operators available, as you can see. So it's pretty flexible. So now let's try performing an update. As you probably remember, when you do an update, you have to specify some kind of criteria. So now I just use the same criteria, and then I'd like to perform an update. There's a class called update with some static properties. I'd like to add to set likes, and I'd like to add, I don't know if this has caught on internationally, but here in Denmark we like cowboy toast. So I'll just add it to Horny's likes. Right. So now this unicorn likes cowboy toast. Yeah. And it can do more stuff, like if I want to add an entire array of things in one go, I can do that as well. That's a really weird unicorn. Yeah. That concludes the live coding. I hope you have gotten an impression that it's pretty easy to get going, and you can get far with just a few lines of code. And you can do a lot with by using the onType because it's totally dynamic and it doesn't care what's in the documents. And you can actually still use strong types, even though there's stuff in the documents that can't be deserialized, because you can add a special field that's a kind of dictionary, and then it would just add the remains to that field, so that when the strongly typed object is saved again, it will retain all of its information, so you won't lose anything. Right. That was some C# to insert query and update and complex models. Now, let's take a look at a tiny web app sample. I don't know if any one of you went there, but this priority queue thing is actually a tiny thing I made, and I used MongoDB to make it. It was an obvious candidate for this kind of tiny web app. The purpose of priority queue is to collect questions from an audience during a presentation. It should allow the audience to vote on questions. It should be easy to find the session that you're currently at. And so that became these requirements. It has to have a session, which is a document, which has a title, location, a duration, and some questions. And each question has a text and some votes. It should be possible to create a new session. It should be possible to add a question to a session, but only if that question does not already exist. It should be possible to increment the votes on a question, but only if that person has not voted on that question before. It should be possible to search for ongoing sessions near your current location. So if you're at a conference like this, it should be really easy to find the session you're sitting at. And it should be possible to show all the ongoing sessions. And as a final requirement, it should be fairly accessible from both desktop and mobile. So I hope I have succeeded in that. It looks like this. This is the create session view. Give it a title, and then it uses the HTML5 API for geolocation, and it tries to get your current location, and it plots you in on a map, and then you can modify the location if that's not correct, and then you can set an expiration time. And when you go to the root URL in the application, you get this view. It will use the HTML geolocation API again, and then it will query the server for currently ongoing sessions within some radius of where you are. So if you went in here, I hope you found the frictionless persistence in .NET presentation. Okay, great. And if you enter a session, you can ask a question, which is just a piece of text, and then you can see all the questions that have been asked, and each question has a number of votes. And then if you have not voted on a question already, you can vote by clicking here. And if you have already voted, then there's no link. So the model in this web app was, obviously the session is the document. And it has a headline and duration as fields. And then it has a tiny document, or it hasn't, with the location. If the geolocation API is not available on the device when you're creating this, then there's no location. So it can be there, or maybe it's not there. And then it has any number of questions, each consisting of text, a number of votes, and then an array of voters. So we can remember if some particular person has voted. Yeah, as I said, the session is at the document level, and it has, for example, this array of questions. So one of the requirements that was a little more complex was that we should be able to add a question to a session. So with MongoDB, I can do this with one update. I get my collection, I have a text, then I set as the criteria the combination of the ID has to match the session ID, and then questions.text should not contain text. So here I'm using they call it reach into objects. When I put a dot in there, it will go into the object, even though one of the objects may be an array. And here my questions is an array, and it will go look for the field text, and it should not be in there. So that's the criteria for my update. And my update consists of adding this question object to the set of questions. So, and the result is this. That's, that was pretty easy. And another fairly complex update was to increment the votes on a particular question. And that can also be done in one single update. So the criteria for this was that obviously that the ID matches the ID of the session, and then that the voters array on the question at index 1 does not contain the name of the person who votes. And then the update consists of both incrementing the votes counter on the first question, on the question at index 1, and pushing the name Joe to the array of voters on the question at index 1. So in one atomic update, we can make sure that all our invariants are satisfied, and there's no contention, and there's no transactions or anything involved in here, and this will just scale. It will scale. So I think it's pretty elegant. Of course, first time you look at this, maybe it looks a little weird, but you'll quickly get used to this syntax. Okay, then, and each session has a location object, which just consists of 2 floating point values, latitude and longitude, I think it's called. And here I'm taking advantage of MongoDB's geospatial indexing capabilities. So any object that contains exactly 2 floating point values can be used for creating a geospatial index. From C#, I do it like this, just say create index, index keys dot geospatial on the location field. So yeah, and in the Mongo shell, I use the ensure index, and I just, instead of 1, I say 2D. And then my geospatial index can be queried with the query.near operator. So given that I have the coordinates lat and lng of the where to search, I can query for all the documents with a location within max distance. So I think it's pretty neat. Any questions for this? No? Great. Okay, yeah. Yeah, I should probably do that. I'll just see if actually I should add some kind of auto update thing in it and just leave it running during sessions like this. Just go in here. Yes. Oh, there's a lot of questions. Great. I'll just in code, when I do a find, it's just a cursor that's returned. So I think I can say something like set sort. It all starts with set. Yeah, set limit and set first and set how many to skip and set the sort order. Maybe it's just sort by ascending. And then which fields to sort by. So I don't know if you can sort by location, if that makes sense. It actually does that when you query with the .near operator. It sorts by distance. But to sort by name, for instance, you do it like this. So it's pretty easy in C#, and it's very similar in the Mongo shell. You just specify a document with the name field set to 1 and -1 to inverse. Yes. Yeah, there's an F# driver. Testing, great. Vote for that one. No, No, I have not tried migrating anything, but I really have a wet dream of rewriting the mortgage deed administration system I was involved in .NET, and rewriting it and using MongoDB to store aggregate roots. It was pretty domain-driven, and we had a lot of trouble getting in Hibernate to perform. How to view the address from the Unicorn collection. Didn't I do that? Yeah, who asked this question? No, great. I think I did that. Right. So now my priority queue is empty. Okay, my conclusion so far, and the rest of this is going to be fast. I think it's been very easy to get started persisting some data. Obviously, you saw me do that in a few seconds. It's been very easy to, given this tiny domain, to satisfy my invariants and make sure they are will never be violated. So actually, that's kind of like the consistency promise that relational databases give you. Then it was very easy when I was developing to extend the model with capabilities, and the database it has no schema, so it just went along, and I didn't need to do anything to add these things. Of course, I have to handle a little more in my code, because maybe my session document has a location, maybe it hasn't. So I have to handle this, but that made sense to my domain anyway. It's been very easy when you're developing. It's very easy to go to the Mongo shell and just do some queries and look for the database and do some explaining and see if your query will work, and then move it to C# and implement it there. And it's been very easy to just run my local MongoDB and do some testing on it. So and then at the end, I deployed my app to App Harbor, and I use Mongo HQ for hosting my MongoDB instance. It's free for instances that are smaller than 16 megabytes. So I can recommend that. So now for the rest of this session, I'd like to talk about some bigger usage scenarios, because I come from sort of an enterprisey environment, because I'm a .NET developer, and that's just reeks of enterprise somehow. MongoDB can be and is currently being used as the event store in a CQRS solutions, and the brilliant and service bus committer Jonathan Oliver actually has MongoDB support in his event store project. So it's pretty easy to get going using MongoDB as an event store. And obviously, MongoDB's flexibility makes it a great candidate as a query store, because it's just so easy to add new views and use the ad hoc querying mechanisms present in MongoDB. So I'd really like to build large enterprise solutions with using this. Then some guy used MongoDB as a distributed cache. It seemed to be very easy and performant, and so that's you can go there and read about it. Then I have in my current project that I'm involved in, I use MongoDB as a central logging database. It took me 4 lines of XML as my log4net configuration, and then I was running. So it was very easy to add logging, and now I can query my log statements with the regular expressions. I have an index on the date, so I can query by date ranges, and it's really fast. And a really nice feature of MongoDB is that you can create capped collections. So you can say that this collection is supposed to be not more than 5 gigabytes in size, and then it will just start deleting all the old documents when it becomes greater than 5 gigabytes. So it's really great for logging. And then if you have tried to do domain-driven design and big domain models in .NET using a tool like in Hibernate, for instance, then I think you'd like to try use MongoDB and support for inheritance and complex objects, and just save an entire aggregate root and fetch it in one go. That's pretty cool, I think. Yeah.
What if you want that?
Yeah, then as well, you can MongoDB actually has a mechanism, a special object called dbref, which can model a reference to another document in another collection, or the same collection if you want. So MongoDB actually has some kind of representation of this, and several drivers take advantage of this to implement some sort of mechanism that makes it possible to walk the graph in the language. But from object to object within the object graph, I don't know if that will be kind of messy, I think, but that could be necessary, of course.
To have redundant data, so if you have a relation, instead just take whatever you want from one party and put it in that other document, and that will work fine. You will have redundant data, but the speed will be, well, as fast.
Yeah, that's true. It's pretty common that people denormalize their data like that, and so it's like the data is owned in one collection where it's a document, and then when it's instead of referencing it from other documents, you just embed the pieces that are supposed to be used there, and then perhaps an ID or something, so you can retrieve the original document if that should be necessary. So yeah, definitely, people denormalize their data. So yeah, that's one way to do it. Yeah, and then to be fair, I had to add some sour spots after all the sweet spots we need. I think I need to mention some sour spots. Obviously, and we touched this a few seconds ago. Heavily interrelated stuff. It's pretty hard to store that in MongoDB. That's probably more suited to use something like a graph-oriented database like Neo4j, or I don't know if there are others, but it's pretty hard to do this to do a lot of complex relations between objects with MongoDB, and then relational and transactional stuff. It's also hard, and some data is in fact relational in nature. So that's just actually it's just me mentioning all the points from all the other sessions. That's NoSQL is about using the database that suits your needs and not about suiting your data in for some particular database. So think about this. And there are probably some other sour spots. Lastly, some ones who's using it. Blockstars were the first company I heard about that shoved more than 1 billion rows in their MongoDB, and they still performed, and it worked pretty good. They obviously you get some issues when you have so much data, but they have so far they have been able to resolve all of them, and they blog about it here, and it's pretty interesting. Then The Guardian have recently moved to MongoDB for their website, Guardian CO UK, and attachments.me are using MongoDB, and they have a nice blog post on how they tuned their MongoDB performance. MTV Networks, the organization behind MTV and several other television channels, are currently they are building their next generation CMS, and they base it on MongoDB because it just suits their needs. Then Foursquare, this social thing, this location-aware social network, they're using MongoDB for their stuff. Yeah, that's it. If you want to read some more, I can recommend this book. It's pretty short and terse, which is pretty nice. So there's no fluff in there. It's just straight on. And then some cool resources. There's the official website, which actually has some pretty good documentation of all the aspects of MongoDB. There's a guy who created Mongly.com, which is the home of the little MongoDB book, a free and open source MongoDB book, and some really cool interactive MongoDB tutorials in the browser where you can interact with the real MongoDB and write queries, and you're given little tasks, and it's really funny. I got all the unicorn stuff from there, by the way. And then there's Christina Chodorow, I think she's called. She works with 10gen, and she blogs a lot about MongoDB on snailenderturtleneck.com. Then there's MongoHQ. I mentioned that. You can get free MongoDB hosting. There's a GUI tool to administer MongoDB instances. It's pretty easy to use. And then I actually reserved some time here to look in the queue. But I think we. Does it have a GUI? Yeah. I think there's no more in the queue. And the last wise words from me is I want to quote Darwin and say that it's the one that's most adaptable to change that will survive. I think this one is pretty good. So thank you for listening, and if you have any comments or some personal feedback or anything, you can reach me here. Thank you.